All furnaces have some sort of components, gas train, which all these components and everything I'll actually discuss in greater detail when I discuss about the boiler components. But primarily just furnaces have all the same setup essentially as a boiler, with the exception of you're heating air instead of you're heating water. And so boilers will take on different safeties and things to ensure you're not going to create steam, etc. Furnace mostly has to deal with ensuring that you have positive ventilation. That's what most of your safeties will be involved with there. Yeah, you want safeties to make sure all the poisonous gases are escaping. Nobody wants so your safeties are going to be different on a furnace as opposed to a boiler. Say your pressure switches, you're still going to want to prove air, but on a furnace you'll have to prove that you have a negative air and a positive air. So that all comes down to your sequence of operation. So what do you have? You have a different styles of furnace. Some, I have not seen a furnace that wasn't, when I say furnace, I specifically reference something that uses natural gas to heat air and with a heat exchanger. So I haven't actually seen a natural draft furnace, so to speak. It's always been an induced draft. So that
I haven't seen one in probably 4 or 5 years.
Really?
Yeah.
I don't know if I've ever seen. I've seen one in school, but no.
Me coming up, they were still blended,
Right.
Mostly induced, some natural at this point. I don't think I've actually seen one in the field in probably at least 4 years.
So it really doesn't, as far as that's concerned, I suppose if you find a natural draft boiler, it's, treated nice. It's probably been around for a while. Primer on the furnace, heat exchanger, uses natural gas to make a fire. You got to vent the combustion gases out. If it's 80% furnace, then you're losing a lot of heat to your flue, and that creates a draft itself, which would be a natural draft, but because we have a forced draft. Anyway, the boilers.
I'm following. You want to go through like sequence of operations?
No, the sequence of operation is next. So you got to understand what kind of boilers we're dealing with before we understand anything. As you can see, the furnace thing threw me off quite a bit, but essentially it's to say that the furnace has many of the same components as the boiler. The furnace is something that we all recognize. We all, can recognize we're heating air, we have safeties, we have gas train, typically a combo gas valve, a pilot, hot surface igniter, some form of ignition. So it's all the same components you'll find on a boiler. The boiler has the added, when I say boiler, I'm just saying anything that's heating water that heats a loop heats a loop, it's hydronic heating. So you're using some heat method to heat water that's transferred to another heat exchanger or some other system. Do you have water tube type boilers? Then you'll have water passing through pipes that is being heated directly by the fire. There's certain advantages to each one. The system with the water tube, you have to look out for mostly have to look out for soot on the water tube style. You have fire tube where the fire actually passes through the body of water. Like I could give examples, but I don't think that I have any pictures to show you. A water tube, I could pull one up on my phone. A well McLean would be a fire tube, whereas water tube would be like a Lochnavar. Lochnavar has water tube. Copper fin too. Lochnavar, you're heating. Anyway, you have condensing boilers. So there could be any of those boilers that just utilize the excess amount of heat trapped in the escaping flue gases. It condenses that, uses that heat, adds it to the loop. They'll be 90% efficient. But they come with their own set of things you need to look at for that. Electric boilers, which are just essentially big water heaters. Water heaters on a commercial scale, I suppose. No doubt, no different. Any of these could be forced draft or induced draft. Forced draft is saying that, and forced draft and induced draft being different, forced draft is, it's got some means of positively pressurizing the firebox, and that's going to positively pressurize your flue. Whereas if you have induced draft, you've actually creating a negative pressure on your firebox and a positive pressure on your flue. And it's just a means of gaining more efficiency or more efficient burn on the fuel.
So one you're pushing air through the heat exchanger and one you're sucking air through the heat exchanger.
Yeah, exactly. I even wrote blowing and pulling, but I didn't even say that.
We run across a lot of these.
Right. Yeah. So in a furnace, that's what I say. The difference is you'll start noticing on a furnace versus a boiler. So on a furnace, almost always will be induced, and that's where you're going to, and all this, the types and what kind, that just leads you to what am I looking at? Like, how do I assess this situation? Because if I'm looking at a furnace, I have a pressure switch. Okay, what is my pressure switch doing? Is it opening or closing? Well, on a furnace, you're going to want to see it open and close. So you likely have two sets of contacts or two pressure switches or pressure switches that shows open and closes. But either which way, you're trying to prove that your flue, for one, is not blocked. So you want to make sure that you have a positive pressure there, and you want to make sure that your firebox, that your inducer fan's on, or that you don't have, in a furnace, you want to make sure that you don't have your two airs intermixing. And so if you had a positively pressurized
You want positive
heat,
pressure in the flue.
but in a heat exchanger, you want negative. If you had positive in your heat exchanger, you'd show you'd have a hole in your cracked heat exchanger, all that jazz. So that's all. The kind of boiler that you're looking at is only important because will help you to assess the situation, assess what it should be doing. Because a lot of times in the boiler, there's no manual, or it's old and it's been pieced together through years and years of hackery, or however that goes. Right. So, if you have any questions about each one of those and their nuances, you can surely ask them. Because each kind will have, for the most part, all the same things, but some of them will be different. Fucking air blows good right here.
Blowing right at you.
It's right at you. It's good because I'm mid-panic attack.
Okay, I got a good job.
So the components that make up any of these boilers, you have gas train, which involves your regulator. The regulator works off, I don't know 100%, so correct me if I'm wrong, but it's a differential pressure. It's seeing a pressure over here, and the spring is perfectly calibrated to have a pressure over here. There's a diaphragm and a spring that only allows a certain amount of gas through. Typically, you'll see anywhere from 5 to 11 inches water column, natural gas pressure before the regulator. After the regulator, at your gas valve, before your gas valve, anyway, you want to see 3.5 to 5.2, somewhere in that range. It depends on high fire. I'd say 3.5 is the standard. Gas pressure you're going to see after the valve going into the furnace. Not a combustion process, but the gas entering the combustion chamber after the valve, after the regulator. It's 3.5 for the most part, but when you deal with low fire, you can have less fire than that and it can vary from the different factors.
So what's the difference between low and high fire?
Low and high fire, you're going to. So in the case of some boilers that have some modularity, or modularity, I think it's the word, yeah, so that it can produce less heat or more heat. So high fire being the maximum amount of heat that it can produce, and low fire being some intermediate before that. And can be all factored in its brain, which can be of many different
So
things.
that's its way of stage heating.
Right. Yeah, there is 100% modularity on furnaces that this guy, I mean the boilers that this guy. And those are complicated. But anyway, so gas valves, regulator, two-stage. And that can be accomplished through different ways, the multiple high and low fire. Thanks, man. So yeah, he's not on one of my jobs no more. Gas valves. Okay, so gas train, we move regulators, blah blah blah. Gas valves. There's a lot of different kind of gas valves. Most all boilers will work in a redundancy, so you'll have 2 of each. You'll have manual shutoff valves, which are just used to cut off gas in case of emergency. Emergencies can happen. Yeah, so it's incredibly important to know where the gas valve is, the emergency gas valve is, in case you haven't.
First step,
First step.
find shut-off.
Yeah, and then remember that. And that's true with anything. Like if you're working with a water loop system, it's like you're on a water source heat pump. In a case where you're working on a boiler, you're probably working on a water source heat pump. Know where that water shutoff valve is. Just like you want to know where your gas valve shutoff is. For sure. Shut off, use cut off, gas supply, user operated, typically redundant, yeah. Know where and how to cut off gas in case of emergency. I even wrote that down. It's pretty important. Solenoid gas valves are used a lot, and so if you have a regulator upstream, and it's typical on older boilers, 80%, and where you'll have a regulator upstream of your main gas supply. So all the gas that your gas train sees, the gas valves, and so you just need actuators, just need solenoids to open up the gas valve. So you can have gas valves that are just pure solenoids.
You're at constant pressure and you just have to open it or close it.
Right, and so in the case of some boilers, and this is where we deviate from how a typical furnace is set up. A typical furnace has another kind of valve called combination gas valve. And a lot of times it's a regulating combinated gas valve so that it produces the right amount of gas pressure as well as the combination by combination, it's combination pilot and main duty. And and that will never see a situation where you have a regulator and a solenoid gas valve, and that's where the boiler starts getting, you can get into the weeds there. They're accomplishing the same thing. It's a gas valve. The difference in a boiler may be that it uses solenoids. Pilots almost always use on the boilers, bigger boilers use our solenoid just on off and using whatever pressure is there. Solenoid combination, same thing. There's another gas valve.
And do you run across like a lot of, you run across hot surface igniters or like electric igniters, or is it a constant flame pilot or? Depends.
You will rarely see a hot surface igniter is not common because you want to ignite the smallest amount of fire as possible, and because you may have a huge firebox and 2-inch gas line, by the time it opens and closes that valve, you can have a pretty large volume of gas that comes out, and so you want to start a small flame. So with hot surface, I have seen there's all forms of ignition.
Well, I'm still thinking furnace, so I'm thinking gas.
Right.
Ignition, and so you have like the sparks, you have the like old school, the barbecue pit ignition looking thing, throws a spark, and then you have the.
I actually have I almost brought it out here, like it's a 6,000 volt transformer. It's a spark transformer. If you can find a 120 plug and get it wired up while you're sitting there. All I'm saying is it would be awesome. Yeah.
So constant flame usually, or?
Standing pilot, I see more than anything, but spark ignition, but it'd be intermittent pilot. So, excuse you? That's what happens when you're swallowing air a whole lot. Right, but we will get to the components of a boiler, and that is a section that you're jumping ahead. That's fine. Your questions will be answered, hopefully. Any questions from you all? Appreciate y'all coming.
Appreciate you taking us on.
Yeah. Trying to waste time. So safeties. Safeties are important on boilers because they are very large fires. And worse yet than the fire, the more dangerous part of a boiler would be steam. The steam explosion being much more deadly and dangerous than gas explosions. Typically, you can usually smell gas. You don't smell steam. You won't smell the pressure that it is before hand grenades.
Look at videos, you'll see.
Do we have you ran across any steam locally?
No, I have not seen a steam boiler yet. I have seen a plant that used to use steam, but I haven't. No, there's no steam generation.
I think that's the only one I know of.
Right.
I know of one building, but we don't service it.
Right. And so that's where the safeties are coming in this factor is because we're saying boiler, we're just a hydronic heater, but so a boiler is just, really something that makes steam. But if we make steam in our process to just hydronic heating, then that's terribly bad, and we want to avoid that.
What would you typically see that happen?
If I don't know if I've ever seen it happen, but it would be because your high limit, most likely you would have probably the most likely scenario that I would see, and this is fairly actually common, is your flow switch is crusted up to this paddle type flow switch, just crusty, closed, contacts are closed. Boiler thinks it's running, so it comes on, proves all its safeties, because it can still prove air, it can still prove all its safeties, and not have flow. And if it doesn't have flow, then it's just going to sit there and boil the water. Say if we don't have a high limit that cuts it out. And that's why a lot of things are in redundancy, but it's just as likely for the high limit to be set to some crazy number or, failed, or the sensor's not in a good spot, or it's rusted out, or however it goes. I think that would be the best case scenario for steam to actually generate. I don't know if I've ever actually seen it. And toss me the water. And so safeties, we want to prove our water. We have some sort of water flow, low water safeties. There's various forms of low water flow safeties. The most common that I have seen is the paddle type, where you just have a normally open set of contacts. It's closed when the paddle swings out, closes the set of contacts, and then however that's accomplished. So it's important to check those. I mean, a lot of the systems we use actually use those paddle type float switches, and those are notoriously stuck in the closed position. And it's important for that not to be happening. And so there's usually a spring on them you can adjust sometimes. Sometimes you can just moving it back and forth will free it up, but something to check. You have a low water where you have an electrode that is, as long as it's submerged, then it's grounded. Once it's unsubmerged, it loses ground, so it opens that. It's a dry contact. I don't know how to explain that. I've tried to understand that, but it's a low water. Once the water leaves the electrode, it senses that there's no water, and it'll open up a set of contacts.
The same concept of like an electronic flow switch?
Yeah, it's the same exact thing that you'll find on a cooling tower. It's the same thing.
But not electronic flow.
Right, well, like the same concept. Right, where it's using the water as a medium to create.
No, so electronic flows don't use water from the medium. They're usually internal.
It's like conductive fluid.
Right, but in this particular case, yeah, you'll lose continuity through ground, and typically, like you're saying, it'll have like a standalone controller monitoring the sensor and then it'll have a separate dry set of contacts that will trigger based off of that controller losing
Oh,
continuity.
okay.
That's what I was playing with that day.
That blue thing, yeah. That's exactly that. I mean,
Right?
you want to go get that bucket of stuff? I mean, I can talk.
Yeah, I can go get it.
It's behind the Jeep, behind the fryer in a big white box. You might, there's a dolly right there. You're probably gonna need it.
The other thing you need help.
Prostitutes?
It ain't even a promotion anymore.
Is there anybody important here? Who's with me? Adrian, Armando, Justin, Kirk, and Greg. Look, look. Yeah. I was actually going to tell a story about Adrian, but he's here.
So how much of this is plug and play?
All this.
So everything that I'm about to pull out here is plug and play. Do you know that it took, like, on that particular project, like, it took, Holden had to show up, and then, because I put all that together, and it was, I mean, I drew it out, you know, so.
I know the struggle. Yes, I know.
So it went back the way it came apart, and then I was like, Holden, this thing's, like, working, and then he, come again? Oh, he did. Hey, I was gonna tell a story about you, but you're right there, so I'll save it till next time. Oh, you just hey, no, whatever. Yeah, I'll say that. Yeah, so. Yeah.
Use it as a video.
All right. Out of the box. Out of the box. Yeah. Yeah. This is 100% plug and play. Okay, so that sucks. All right, so this is what it would look like, the low water, what would I call it? What is it called? What is it called? Electrode style, where there's actually an electrode right here. You have contact here, so that when we make continuity, when we break continuity, we open a set of contacts. And it's typically, it's like something like this, plugged in the wall, just a wooden strange relay. It's got a bunch of weirdness to it. Anybody?
Pass it around. See if we can break it.
Cool. I know I brought this box for some reason.
This is classic. We got toys to play with.
Yeah, see, I tried to get this thing set up and just put this on some 120. Fire death.
Oh, that's a sit-down ball. Whatever you call it. Like that. I'm gonna go get the extension cord.
You got one in the van?
You have a true float switch style low water cutout, and that'll typically be like it'll be a pipe that comes out of the boiler. It'll be like the front of the boiler. Pipe comes out the bottom, and they connect. They have like a bowl right here. It's almost like it's got strainer bolts up here. I don't know if I'm if I'm just flailing my arms around, but
Are you able to draw it? Kind of give us an idea?
yeah, there's a big bore, eh? All right, boiler. All right, pipe comes out. Pipe comes out. Man, this is the product of a misfit youth, I tell you. Let's do. All right, so. All right, yeah, so I mean, from the front of it, you just see the pipe and a bulb. It's cast iron. Kind of got like this lines vibe going on, but I can't hardly draw that too well. So, but internally to it is literally a float, like you would see on like cooling tower, anything. Back of a toilet, it is just a float, comes out here, sees a level of water, which is the same water level that is in this boiler. Typically you'll see this on the fire tube boilers, right? Because here we're heating a body of water. It's got tubes in it. Let's call these tubes. And the fire's down here. Anyway, so that's a safety you would see on a fire tube boiler.
Okay.
The drawing went off kilter. Yeah.
So, how many of that style do you see versus the Electrode?
It probably the same amount. There's less of these maybe. This is not as common, but yeah, this is fairly common. It's as much as the Electrode. I think the Electrode's kind of older. Mostly I see as the paddle style float switch for sure. These are important to take apart and clean because this gets all crusty like the float switch, and you can actually, that's why I drew it like such, because you can take that off. Of course, it'll have valves, it'll have quarter turn valve, valve it off, it'll drain, you pull it out, clean it.
And is that for flow or is that for water, low water?
Low water.
Low water, okay.
Right, yes, and this is just low water, and flow being different than, in this case, I think that, than low water, it's based off the boiler type. What's that?
Do you know more about that than I do?
Fucking blind dog finds a bone every now and again. All right, so yeah, airflow proofing. It's the same sort of pressure switches. Open contacts, close. Usually it's forced draft, so you want to verify that you have some sort of a positive pressurized flue. Make sure you don't have a blockage.
Do you find many birds in flue stacks?
No, because our flues are huge.
That's
And so like typically I have seen fire and smoke come out of a flue before.
Oh, yeah. Yeah.
Not exactly sure to this day how that went about, how that came to be. Maybe. It was very black. Yeah. Fire, danger, death. Yee! So you have some sort of high limit. That's just a pressure temperature switch. Opens, closes. Various forms of the high limit to perform various functions of the boiler, depending on how smart it is or how it uses, how it comes about no and life. You have gas pressure, so you have pressure switches measuring gas pressure. Open on a rise. That way, if you have overpressurization of gas, like your regulator fails, it'll shut off the boiler. Really, I don't see a lot of gas pressure.
Is the inlet outlet pressure important?
As far as specifically, as the pressure gauge, the pressure switches.
No, it's like what's coming out of the wall or the pipe, and what's actually being burned.
The pressure switches, the gas pressure will be on after the regulated pressure. So it'll be nothing above 3.3 inches water column.
Regular column.
Right, yeah, your furnace, it's all the same gas pressures you'll see as a furnace, right? And same low fire, high fire situation. I mean, it's exactly a furnace, it's just heating water. There's certain additional thoughts involving water, but nevertheless, it is exactly the same. But same pressures and principles of hydrocarbons breaking down in dramatic ways, releasing heat as energy, combining with oxygen in the form of water, even. Yeah, so that's a high limit right there. Right there. Yeah. I forgot I had toys.
high and low fire.
Yeah,
I'm putting things together.
high fire. Take it away, John.
Here. High and low fire.
Right, and this is just a temperature probe. It goes in a well. This is your well. Looks like this.
Show the camera.
Yeah, take the whole thing.
Take the whole thing. I can't be your helper.
You gotta be my Vanna White.
Okay, I'll be your Van White.
Alright, so yeah, this is
There
a
you
pressure switch. I mean, you got temperature. You set your temperature. In this case, what is this doing? This was set up so that we had a low fire and a high fire. And that takes some explaining to determine what we're going to set our temperatures to. I think that's beyond the scope of what I can discuss here. Nevertheless, this is a switch. It has probe, which I believe is just like a TXV bulb and is heated to pressurized gas. And so you can't.
Change those out, just want to make sure it fits the well.
Yeah, and so the interesting factoid is there's multiple well sizes. There's multiple tip sizes. Yeah, who would have figured, right? And they only fit together in a one way, like it's 1955. And so, what was I going on about?
Basically, your high-low, that is your essential thermostat control for the system, yeah?
Yeah, in this case, this was set up as the control. So we have a high limit. So we're set to say 220. We're going to open the contacts. They're normally closed. They're going to open once we see a rise in temperature above our set point, which is this one is 190. Because you don't want it above 200 because you don't want to make steam. In this case, we just had our low fire set to 100 and whatever, 40, so that 140 degrees and low fire came on, or that takes some other explaining that I'm not prepared for. Temperature switch, and doesn't that work off the same principle as the TXV? It has a gas in the bulb that heats up and then opens it.
It's got a diaphragm.
It's got a diaphragm that closes and opens the set of contacts. Right, and you can set those to however you want. You want them open on close and open on rise, which is close on rise, open on rise. I think that's the simplest way to understand it.
Close on fall.
Close on fall.
Close on fall, open on rise.
Okay. All right. High limits, gas pressures. I think that's all the safeties. Water. We want to prove our water. We want to prove our air. We don't want to get too hot. We want some sort of controlling factor.
You said 200's our limit kind of thing?
But I use this rule of thumb as far as like yeah, I mean 200 is probably the high end, is a high limit I would say. For sure, because you don't want to get too hot.
What would be a standard operating temperature for?
Like if you were on your high and low, what are you gonna set at? Probably like 190, 180 and.
Well, their loop temperature, 140 is probably just like your. I want to set a temperature that I don't really got an idea of to. Just set it to 140. It's kind of dependent because I mean, if we're heating up our purpose, if we're heating up water to heat up a loop that's heating, say, using that water to water source heat pumps, that's condenser water that we're dealing with. So in this, we want to maintain a loop temperature of, say, 75 to 95. But our boiler is going to, so there's going to have to be some interplay there. So our boiler is going to probably produce 140 degree water that's going to match with this 60 degree water. And then that combined water temperature is going to need to be a certain temperature.
So I'm guessing we have
Are
some
there
sort of
differences-
mixed temperature.
Are there differences in heating loops to feed water source heat pumps versus directly feeding fan coil units?
Well, as far as, what do you
The water temperature?
Yeah, I suppose the water temperature is going to be a huge factor because, and in the case of the water source heat pump condenser water, you could be monitoring your return water as well. And so you'll see this, as long as you have a consistent return temperature, then what's ever coming out of it, it'll figure that out. That's like hydronic heating, and I don't really understand like how that's actually working, but suffice to say that your temperature is going to be contingent on the system. Because if you're heating fan coil units, you may see 180 degree water, 170 degree water. Like, it could be hot because you want hot air, but 140 is probably the standard that I know of for sure. Anything to add to that? I feel like I'm missing something there.
We could go into a little bit on like why we're like how the low and high fire stats control. I can help
So like in the case of this guy that's controlling high limit, it's going to open a set of contacts. It's going to stop our boiler once we reach too high of a temperature, and this, let's say 180 degrees. Our low fire, and we also have the high fire in conjunction with this. So I'd say we're going to say our low fire probably like at 180 or 100. We'll say we're going to maintain a loop temperature of 140 degrees. So we're going to set our low fire to, let's say we're going to maintain a loop temperature of 160 degrees. We're going to set our low fire to 160 degrees. Because anytime that it's going to close a set of contacts on a fall in temperature. So it's going to want to it's going to keep the contacts closed until it sees 160 degrees. But high fire will open.
It's like a deadband operation. It's opening at the high end and then closing on the low end.
Because you'll see 140. Say your high fire is set at 120, and your low fire is set at 160. And so you know how do you reason with this? It's your 100. It's once your temperature, say your loop gets below 140, that's when your high fire is going to kick on. So anything between 140 and 160 is just going to be low fire.
So it's kind of like backwards of what you're thinking.
It's backwards from what you're thinking, and I think that you may be able to explain that better. But it is that you're keeping that low fire on. Your low fire is your thermostat in this situation where it's going to respond to any temperature below 160. It's going to come on.
Y1.
What's that?
Y1.
Y1. And if in the case, okay, yeah, in the case of a furnace for sure, yeah. Anything below 120, the high fire comes on. So it comes up to 120, high fire goes off, and then low fire takes over from there. And so that we're not creating two huge heat swings. That's a low fire intervals sort of situation.
That makes sense.
Yeah, that's that low fire, high fire. That's how those pressure switches work, and that was a like. How does that make sense?
No, because I was just staring at this thing, and the low fire side is set at like 200, and the high fire is set at like 185.
Huh?
So it's like, why is the high side set low and the low side set
Right.
high? And now I know.
It's one of them things that don't actually make sense, but
Yeah, it's working reverse theory from trying to cool, trying to heat. So everything's getting cold.
Well, I was thinking like your high temperature should be your high number, your low temperature should be your low number, but no, it's calling for a stage at a low. Yeah, it makes sense now. And that explains why I was like over there like,
yeah, because you look at the. I imagine.
well, no, I'm right here. Yeah, right here, look. 200 and 185. It's marked.
Yeah. Yeah, and those particular ones were subject to misdiagnosed pretty strongly. They were seen as a failure point, but I don't think so.
Say that too.
I think that led to a discovery, though. That was a good experiment.
Learning.
So there's flame sensing improving. All the boilers are going to have some sort of flame sensing improving, and this is the same as the furnace. Flame rod, it just senses the current produces by a flame. I wish I had one of those too. I wish I would have brought it. It produces AC currents rectified to DC, and that's what you'd read at the controller, which is here. AC is rectified to DC, and then you got a flame current. Yeah, controller, old school, not before the old school, but after the old school.
Old school to us.
It'd be old school to us for sure. But actually, same one. Yeah, and that's another component. That's a controller. Yeah, and then to translate that to ignition control board, ICB, ignition control module, ICU. Yeah, and even some of those Honeywell black ones, they can be found on boilers as well. So all that same theory that goes into the burner controller on the furnace is the same. It's the exact same thing that's in it. We can go on with it. Flames, you sense flame with the sense rod. It's seeing, making sure there's flame. It uses flame, produces a current. The current's picked up by the controller and it establishes that we have a flame. It can also have a UV sensing light, or it's not a sensing light, it's a UV detector, photocell. Many call it I-type, and that just sees the UV light. It establishes that you have a flame. It could be either one. I don't know if there's another type of flame sensor. I've only ever seen the two. And a lot of times your spark igniter can be your flame sensor on a boiler. It's the same rod. Only thing that makes a flame sensor or anything is it's got silicon coating on it, but it's just a piece of stainless steel. You have controllers, some sort of means of burner controller. This is where all the sequence of operations happens. This is the brains of the operation, so to speak. It's going to see that you have safeties met. It's going to make sure that safeties, turn on your gas valve, turn on your pilot valve, give you an opportunity to test. Interlock all your interlock circuits. Let's make sure I'm not forgetting nothing there. Thermostat, UV, your your safety. So you're going to establish that flame there. Your limits, pilots, gas, burner, L1, L2.
Is there a sequence of operation on it?
No, not on this one here. The book itself would, for sure, because it's going to, it'll have a sequence operation. Because this one's going to, and pretty much it might be, because you look at the back, you can make that determination.
What would be a standard sequence on, just like say a force drive?
Oh, what's that? Force drive. Force drive standard sequence operation. Say we have we'll have intermittent pilot, force drive. Yeah, so we're gonna we have a call for heat. Oopsie-doodle. Call for heat. Boiler recognizes that. It brings on it may have a booster pump. It may send the signal to the building pump, but nevertheless, it's going to verify that it has flow or establish that it's flow. Once it's established flow, then it'll establish airflow, bring on the inducer fan, or in this case, it'd be some other kind of fan, but we'll call it an inducer fan, a force draft fan. Once we've established we have a draft, what did I say, spark ignition? Spark will ignite a pilot assembly, typically. That will be proven with a low reading on the flame controller in some cases. Establish we have a pilot, it's going to open the main gas valve, and at that point it's more likely to recognize see the flame sense. So, yeah, I think I went off a trail, but prove water.
Is that checking for continuous operation?
What's that?
Is that checking for the continuous operation once it's lit?
So this one is not. The newer ones will. They'll see a lower flame current on the pilot than they will on the main fire, typically, and even as it gets hotter. But I don't know. I haven't dealt with many continuous pilots. I feel like that's not typical on a boiler. Like a standing pilot.
Okay, yeah. Because I'm not thinking of standing on it, I'm thinking of electronic connection.
So continuous operation, I'm not sure what you're referencing, perhaps.
Like, in the furniture and IOC, it's integrated furnace control.
Right.
And it's gonna go through its, 8 steps, and then it's gonna continuously check that thing running right, like your flame sensor and your...
I see. So is it continuously analyzing the situation? So I think in the case of this guy, it's just interlocks. It's just logic. In this case, it was relay logic. You know, so
Something will
open, and then that will open this set of contacts in here. But it's not continuously reaching out to see if we have a flame again. It's not continuously reaching out to make sure we have flow. It is all interlocks. This is safeties. I can't think of an instance where I can see where it would be beneficial, but I don't know where I would see that. If I have, it's been limited. But yeah, sequence operation. It will be different for each of the each kind. So you'll have whatever sort of pilot assembly, or not pilot assembly. How would you say it? Whatever ignition system that you're using will determine your sequence of operations, and that's important. I didn't list out. I mean, that's pretty fair, easily defined as your sequence of operation. Basic sequence of operation. We're proving we have water flow. We're proving we have airflow. Open the gas valve. Prove we have flame, and then satisfy in the reverse order. Closing the gas valve. Shutting down the flange. Shutting down the water. That's a very simplified approach, and it can get much more involved with steps that it's trying to verify and prove different factors. But but overall, it's verifying those factors. And so if it's a hot surface igniter, then your hot surface igniter is going to come on before your gas valve, and it's going to stay on for a certain amount of time, and then it's going to prove flame. And it may be that your hot surface igniter is what proves flame. That's fairly common. If it's a standing pilot, or if it's intermittent pilot, then it's going to, same thing, it's going to light the pilot off, establish a pilot, and then bring on your main gas valve. If it's a spark ignition, it's going to bring on your gas valve essentially at the same time as your spark is getting ignition. This guy. But that's all. You got to figure it out. I don't really know, I guess. Anyway, anecdotal stories time, because that's all the information that I could come up with. What do you get? Quick questions.
What are the main brands?
Name brands? Like boilers. Lochnavar is one of the more common ones around here. Well McLean. Here, better yet. We get into the burner controllers and such, then there's a standard burner controller. They're all modular, so you may see one standard burner assembly on what is I don't do good with the names, but I have them all where I've got them. Dead silence. Nobody saw it. Nobody talk. Anyway, so yeah, I can't think of them for the life of me. That burner, because the burner assembly itself is common to boiler types, regardless if it's fire or water tube or what. But that. Come on, buddy. It's not in front of everybody.
Did you touch on Flue Gas Analysis?
Raypack is a brand. Brian is a brand. Will McLean is the is that? No, that's that. I'm thinking. Okay. What? Cyclonetics, JBX, Cyclonetics is a burner assembly that's fairly common, and that one is interesting because I actually have worked on one where there was one that was older than this. That was a physical computer, a mechanical computer, and such as that it just spins, and the way it could close and open contacts was logic relay that was all, I never understood it. It was really fucking cool. I wish I could have kept it, but suffice to say that all the burner controllers still are using that same setup as I found on that boiler to the ones that I found that are brand new, and that's the Cyclonetics. I don't know if it's still called Cyclonetics. JB burner, yeah, Webster combustion. They're all the same. But yeah. Touch on no flue gas analysis. No. No, you want to stack temperature below 400. You want your excess oxygen 8 and CO2 below 200. No, CO below 100. So,
Parts per million?
okay, let me pull one up here. And this is a work in progress because I'm actually right now in the process of trying to better understand what is the flue gas analysis so that I can actually translate that in. Believe it or not, I kind of understand the things in my head better than I can say them, only by a margin. So, percent excess oxygen. So flue gas analysis, you're going to pull out, you're going to do a flue, test the flue gases, you're testing for efficiency amongst other things. I really didn't plan on going into this, but it's fine, I guess. Stack temperature, you want to lower stack temperature. The lower your stack temperature, the higher your efficiency, because that is...
Need to be put into the water or whatever medium you're going.
Yeah. I mean, it's either going out the roof or it's going to the bottom. I have right here, I have a very high efficiency gas, probably 90%. Yeah, it's literally 90%. I have 125 degree stack. I have a 7 degree oxygen saturation. That's percent of the flue gas as oxygen is 7%. In standing air, it's 20%, 22%, whatever. 19, I forget. And so that's showing you how efficient your combustion is, how much of that oxygen you're using. You want to use, it's like 8 to 10, I think is the number. Parts per million, CO2, CO1, carbon monoxide. You want less than 200. I think most things say that if it's above that, you should shut the thing down. It can kill people. Because CO2 is heavy, carbon monoxide is heavier, it will fall back down the flue if it's an old crusty natural draft flue and all that. Yeah, and that's the only ones that I know. And there's a percent excess carbon dioxide as well. I think it's 10, but I don't remember.
At 10%?
10%, yeah.
Do you have a heat exchanger in the water?
Right. So yeah, the heat exchanger in the water it'll present itself in different ways. So like in this case, this guy was a water tube. A fire tube. So in this case, you have a volume of water, and I think the Will McLean boiler. I mean, they usually come together modular. There's so these are like sections you put together, and they close together, and they make like a pot. And so you have like a cavity with water. And then there's it goes like, and then you put another plate on there. It's a cavity with water. And so your water is being piped through here. And so your water here, and your fire is coming up from the bottom, going up, out the flue. Right, I think if my drawing.
That's a fire tube system?
And that's a fire tube system. And so your fire is passing through a body of water, a container of water. Whereas where very well may be that you have, in this case, you just have a header. Water comes through, goes to the header, and it's just a series of copper fin tubes that go to your loop. And then the fire heats that, and it just circles through there. And that's a water tube. There's another type.
What happens when those get penetrated by water?
Well, if you lose water here,
You know, if like those that rust out or
you have a huge leak. It's obvious.
It will present itself.
Yeah, if it's a small leak, there'll be a lot of corrosion. Like when you're doing your maintenance and stuff, if you were to look up at a water tube boiler, and this is common in copper, the Lochner have a copper fin, and that's a water tube boiler. And what is typical is these will leak here at this flange, and you'll see like a lot of corrosion. And of course, and corrosion being a great an insulator, it really, really fucks with the boiler operation. And so that's going to create a lot of excess CO that goes out the vent. Any sort of corrosion on this is going to really severely hurt it. That's the problem with a water tube like that is if you get any soot, the soot pretty much ruins it. If you have a natural gas boiler, you look under there, it has soot, it's pretty much totes for the, it's replaced. We've actually, I think that was the problem at one of my first adventures. Because that's the one that we've seen soot rolling out of the side of the building. And soot is an incredible insulator, and it will cause the problem that it's caused. It's like, they go hand in hand.
What is if you're done with that transfer, what is a basic boiler annual look like?
That was the next question.
Read the manual. And do what it says. I mean, that's not to be funny, but, and I obviously will elaborate, but, that's a manufacturer saying what to do. If they say that once a year you need to come in and ream these out, then, that's what that is. Typically, though, you will never enter the water side of this unless you've seen a dramatic low split. That would present itself as a problem through the gauges, and you really wouldn't need to pull it apart. So a boiler annual, you're going to check all your safeties. Like, incredibly check your safeties. It's make it fail the way you would want to see it fail. Make it work the way you want to see it work. So in the case of a flow switch, turn it on, check your continuity. Turn it off, check your continuity. Well, not check your continuity while it's on, but verify that your switches are closing when they should be and opening when they shouldn't. Especially on the simple float switches and all that. Any maintenance will involve that. Checking your tightening your electrical connections. Checking your flue. Putting your phone up in there and making sure you have a flue. A lot of times it involves pulling the burner rack out, which is a lot of times very involved. But that's where reading that manual comes in, because the manual says that you may never need to service the burner rack. Well, then maybe just look at it. If it says that once a year, scrub it with water, that's where that's going to come into play. If it's no manual, then it's better judgment. But go clean the burner rack, pull the burner rack, clean it, which may involve vacuuming it, may involve scrubbing it with soapy water. Depends on the material. Stainless steel, you can usually scrub with soapy water. Cast iron, you just want to vacuum. Flue gas analysis, measuring gas pressures, verifying we have proper gas pressures during high and low fire. And that's being compared to what the manufacturer wants. A lot of the type that use a burner controller, what's that called? Where the modular system where they're using the burner system that's separate, it can be bought separate. You'll check the linkages on that. I now can understand what the linkages, for the most part, should be doing, but I don't think they're just checking, making sure that they're there and they're tied. Fan amps, if there's any fans. But I think the overall is checking the safeties, and that's probably one of the more involved kind of mind-scratching things that you have to do that's unique to a boiler is verifying the safeties. And admittedly, it's been a growing experience where I've learned how to check safeties as I've gone on. So, Ambrose was the first one where I was very confidently checked all of this.
Except for one particular piece.
What's that?
I said except for one particular piece that wasn't technically safe.
Oh, yeah, that was a while back. Yeah. You can also set yourself on fire.